Pew pew! I got you, players. In the previous video, we built a simple Discord bot in Python that can communicate with Llama model over REST API. It stores the conversation context in memory and gives the most basic experience of chatting with an LLM over Discord. My name is Janek, and in this video we will make our bot a bit less junky and expand its features. Today I will show you how to speed up responses from Llama.cpp Python API by adding CUDA support, add the system message to context, which will allow us to control the bot's persona, reply to direct add pings in channels and respond to DMs, persist the conversation context, use the openai Python library to simplify the communication, add an option for single completions with no context. First, we need to split this project into two separate parts, Discord bot and the LLM API. Contextually, there are two independent parts, and the completion API served by the Llama.cpp Python can be substituted by anything else that's compatible with the openai API. Let's move to the terminal to kick it off. We first need to change our project directory. We will start by removing our virtual environment. That's because we will create separate environments for each of the parts. Let's create two new directories, dbot and Llama API. Before we even touch the bot code, we will start with setting up the Llama.cpp Python API. We will be installing the latest version, and in my case I'm also going to set it up with CUDA support for offloading to GPU. Before we install the API server, we first need to force the compilation of Llama.cpp with CUDA support. This is described in the Llama.cpp Python README under the installation with various BLAS methods. BLAS stands for Basic Linear Algebra Subprograms. I will install the kublas Llama.cpp Python package and add the dependencies for the API server afterwards. I'm adding the no cache dir at the end to force the download and compilation of Llama.cpp. By default, pip would use locally cached packages, and if I installed it without the CUDA support in the past, it would not recompile it. Keep in mind that the command I'm running here is specific for the NVIDIA cards and requires CUDA to be installed and configured with the access to the NVCC compiler. If you have an AMD or Intel GPU, you can compile it with the CLBlast with OpenCU SDK. You can refer to the Llama.cpp README for more details about BLAS support for various different libraries and GPUs. I'm going to link it in the description. With Llama.cpp Python installed, we can now install the API server. Remember to use the quotes for the package name, otherwise the shell interprets the open square bracket as test condition. Finally, we can test if it all worked. Over here, I'm using the new Llama 2 7B chat model with the 2-bit quantization. I'm specifically selecting the smallest possible model to have quick responses. I don't care about the quality during the development. Take note that we now add a new option to the command, the ngpu layers. This defines how many layers of the models will be offloaded to the GPU. Different size models have differing amounts of layers. For best performance, you will want to offload all the layers. Keep in mind that the more layers you put in the GPU, the more VRAM it will require. And when it's starting, we can confirm that it does in fact support the GPU offloading in the debug output. I'm going to open a new tab and let's give it a quick test with curl and our previous payload file. As we can see, it works, and now it is incredibly fast compared to running purely on CPU. For the rest of this video, I'm not going to use the locally running instance, but instead I will be connecting to another machine running Llama.cpp server. This computer is running the same model with the host binding of 000 to allow the listener access for external connections within the network. Okay, with that running and usable, let's move on to the bot. Starting with a new terminal tab, we'll cd into the same directory. The chat and the bot Python script, which we wrote last time, are mostly the same, and we don't need the chat UI. We'll write a new module that will also provide CLI chat. Let's remove this one. We will start by moving the bot PY to dbot directory and going into it. We can create new virtual environment and activate it. Now, last time we wrote a really junky script that had no error handling and was pretty much thought out on the spot. Let's try to do a bit better this time and actually think first of what we need to do. Let's go to the drawing board and try to plan out what our workflow will look like. We want to use the openai library and have ability to use either chat completions or completions. For the chat completions, we need to be able to store context of the conversation. For this, we need to be able to save the context, load the context, reset the context. Context can be stored in a few different configurations: per user, per channel, per user in channel. Per user option is useless as it would be a continuous conversation tracked between channels, which doesn't make much sense. Per channel configuration means that each of the users in the channel can follow up on the conversation context. And per user per channel would mean that each user in the channel gets their own context. Ideal configuration would allow us to specify how we want to handle it in each channel, but for today we will only implement the per channel handling. We will implement other options in the future. If the context length exceeds the max limit set in the Llama.cpp Python API server, it will spit out 500 error. We have two options to handle this: catch exception and remove the context, then retry. This is the most basic approach. Track the token usage in our stored context and remove the old context before the request. Today, we will be implementing the first approach. Before we start writing any code, there is one more problem that we need to think about: the order of messages. To illustrate what I mean, imagine this scenario. We have two users in a single channel, Alice and Bob. This is Alice. She is smiling. She likes video games and kittens. This is Bob. He is not smiling. He's a grumpy old git. This will be our timeline, and this will be our state file. Alice is asking a question to our bot. The request is sent to the LLM completion function, which loads the context from a file, sends the API request to be processed by the Llama.cpp, and awaits the response. Before Llama.cpp is done with the text completion, Bob sends another request, which also hits the LLM completion function, which then in turn loads the same context into memory and passes the request to the Llama.cpp API. Meanwhile, the request that Alice sent got processed and the completion is returned back from the API to the LLM function, which now saves the context of the message and gives Alice the output. A moment later, Bob's request is processed as well, and the state is saved in the file, but now overwriting the context which was given to Alice. Whoever makes the next request will receive the latest version of the state that was written, and it will be missing the context for Alice's question. So how can we solve this? Let's think about the workflow of our communication. We have our Discord bot, we have our completion functions that communicate with Llama API, and we have our context functions that manage the save context files. Our Discord bot can receive message events at any time. They can be sent simultaneously from multiple users. Regardless of when we receive them, we want to process them in order. The easiest way to do that will be to implement a FIFO message queue, meaning that each request will be processed in order it was received and will not be sent to the API until all previous requests are completed. For this, we will use the async IO queue. With this layout, we can start writing our code. Let's move back to the terminal. We will be splitting all of our functionalities into their own modules. Let's create the files for each of them. And we will need a directory for our stored context. Let's install all the packages that we need. And now we can start scaffolding our functions, starting with the context handler. So we said we will need the load context, save context, and reset context functions. Let's implement them. Right, so for all of these, the context ID will be the reference of our context channels, will be the channel name, and that's what we will use to create the file. Speaking of file, it would be nice if we had a handler that can give us a context file name. So we created our directory for the context. Let's set it up and let's create a handler function for it. We know that our context is a series of messages that are formatted as a list, so ideally we can store it as JSON, and we can import OS to handle the file creation. Let's start by specifying the path of our file. So over here we are specifying as file name our file name as context directory, then proceeding with the context id.json. If the context file doesn't exist, we would like to create a default one. This is something that we can handle in the load context function. So let's start by implementing the return of messages. So this will be our default behavior to provide first system message for the API if we don't have any context. But now we actually have to check if we do have any context. For that, we can use path from the path lib, and we can verify if the context file exists. So we're checking if the file exists, then we will be loading context. So there's going to be simple file open and JSON load string from it. Let's implement that. Okay, so if the context exists, we are returning the messages loaded from the context. If it doesn't exist, we return a default messages with the system message to start a new conversation. There's a possibility I made a few typos. We'll see it when we test it later. So now that we can load the context, we also need to be able to save the context. So in the same spirit, we are opening the file name, this time for writing, and we are dumping the messages. As you might have noticed, I already made a mistake because we will need to actually get the messages here. So now we have context ID and the messages. There's another typo I just spotted. Cool, so we can load, save file, and the last thing we need to do is to reset the context. So for the context reset, we will basically just remove the file. One other thing we might want to think of is if the context was already reset, we would throw an exception because the file is not there. So we might want to handle that. Okay, so now we try to remove the file, and then if it doesn't exist, we do nothing, which is fine. I think that's the most basic handling. We can always come back to it and improve it. Let's move on to the LLM request handling. We said we wanted to use the openai, so we will import the openai library. We will need to specify the API endpoint. I'm going to be referring to the documentation provided from the API reference, as well as the instructions from the GitHub. It gives us like a basic idea of how to use it. So we need to specify the API base and the API key. We don't really need it, but let's specify it in case if we in the future want to substitute it with something else. And over here, in my case, I'm running it on my other computer. For you, it might be the local host. So in your case, if you're running it locally, just substitute the IP with the 127.0.0.1, and that's if you're running it on the same machine. Now for the completions itself, we want to be able to have the chat completions and the completions without the context. So let's implement two functions, and over here we need to remember that Discord is a state machine that responds on events, so we need to make these asynchronous so that the responses don't actually block any other events. So that's why we'll be using async. Let's import async, and we'll start with the async functions. Now we have two functions, one for LLM complete and one for the LLM chat complete. Both of them will be calling to the OpenAI Python library using the async create functions from there. So we can copy that from the async API. This is for the chat completion. So over here for the messages, we know that we have our context stored. So we will just load it from our other module. So we will need to import that. Let's do load context ID, and we need to import our previous module context. Also for the model, we are not running GPT, so we will need to actually get the model from the API. For that, we're gonna write our own function that also uses the OpenAI API. So in this case, we're using the models model list, which is also listed in the documentation for OpenAI, and we are returning the first entry ID. We could expand it in the future to list all the models. For the time being, we will only be interested in the first model that is returned from the Llama.cpp. At this point, Llama.cpp Python doesn't support running more than one model, so that's not relevant for us. Now over here, we can try to return our actual completion. So let's do right. So I'm missing some things here. The workflow is mostly there, but we need to be able to append our message to the existing messages. So I think that's something I missed here. This is where we take out the completion message. So this again is the structure from the OpenAI. You can see the response structure over here. So we want to just pull the completion from it. Right, I think my naming here is not ideal, so I'm going to swap it about. But basically, when we do the chat completion, we want to have our prompt. We're loading our messages, and then we're creating our single message unit with the context of the prompt. And then we are appending the message to messages. So we have a single message, messages, and right. And then we are sending all of our context to the completion, chat completion. Parsing out our responses and saving the context. We're missing one part over here where we need to actually include the generated response into our message. So from the chat completion object, we are converting it to dictionary, which will basically create the list of the message, and then we can append it to the remaining messages and finally save it. And we want to return the response message which we got here, so we just want to return the context. Right, let's think of a quick way to test it out in CLI. So let's add a function where we can actually launch this script and query it to see if it works. Okay, so we wrote a very simple loop, basically just like a forever loop that we can control C out of it later, that gets the question input and then runs the LLM chat complete function for us to see if it will output it correctly. For the context ID, we don't really have the channel ID, so let's just create whatever, like call it CLI chat. And then we are creating safeguard to only run the CLI chat function if we are running the script directly. So let's see how it works. And we have our first error. Let's have a look. Of course, I called it context, but I called the file context handler. So let's fix that. Okay, that's fixed now. Let's try again. I cannot type, so I used the wrong quote here. So that's in the completion, in the context handler. Context directory, let's fix the saved context. Yes, the quotes needs to match. Okay, and let's try again. Right, we have input, so hello. And we are crashing on expected string in the LLM completions. Of course, this is because I don't actually return the file name correctly, so I'm hoping you're entertained with my bad Python. Can't even type return. Okay, ctx fn. Third time the charm. Okay, so we're making progress now. We're failing on messages. Where's the typo? Messages SA. Okay. 30 in save context in the context handler. Okay, so context handler line 30. Messages. There we go. That should be fixed. Okay, fourth time the charm. Nope. Okay, so we made a mistake by creating the file. Previous execution must have saved it, and now it's empty. So let's remove the context, saved context, CLI chat. And let's try again. Name response message not defined. Did you mean response message? We have another typo. It's missing O. None. Okay, and we're getting output now, but it's not exactly what we're expecting. So let's look into that.
One eternity later.
Right, so the mistake is that it should be content. Obviously, I haven't typed correct thing. Right. Let's try, what, sixth time the charm? How are you? None. So many typos. Right, let's go. It's gonna be fine now. Let's remove the print. Hi there. I'm just an AI assistant trying to... Okay, so that works, but it cuts off, so we might want to expand the max tokens for the chat. We can add max tokens here. Max tokens equals for the chat completions. Let's do something say like 256 for now. And it does appear that basically this works now, except I forgot comma. Yeah, basically probably all of them apply to me. But cool, we have a working CLI chat. So now we can think of trying to call this function from the Discord bot itself. So of all the things that we wrote last time, we will not need most of it. We can definitely remove AO HTTP because we're not going to make requests in this way. Let's remove all of that. We don't need that verbose information. We can remove the user ID. We are not passing payload anymore and we're not specifying the API URL. We can remove that as well. So that brings us the most bare bone layout for the bot. So first thing we might want to look at is to respond to the at mentions and not the exclamation AI. So at mention in the Discord bot, the way it reports it, you can print it out, print out the message to see the user ID, how they look like. But it will have the less than more than signs with the user ID. So now we can actually check if the at mention contains or maybe starts with. Just start with for now. Start with the at mention. And then we will want to call our actually, no, we need to remove the at mention from our message. We don't want to pass that to the ALM function. So let's do this. So now we're stripping the message of the at mentions, which is using like simple string handling in Python and stripping it for any extra characters like leading or trailing spaces. Then we can pass that on to the LLM function. So let's do completion response. This is where we'll need to import our LLM completions. So we need to pass the context ID. We haven't specified a context ID yet. Let's set our context ID to the channel name. Okay, so once we get the complete response output, we are passing it back to the user. So we can test if it works with our chatbot, but this is not the final form. So basically, this is just to verify that the bot itself will work, but we will need to implement the queuing after that. Okay, bot is running. Let's test it on Discord. And we're getting first error. Cool. No attribute I. Oh, this is my fat fingering at Vim. Let's fix that. Try again. Some more errors. Name strip is not defined. Oh, it's slow. Cool. We have a response. Of course, you don't have feelings. Okay, so it does have context as well. Let's check how it looks like in the file. Cut, saved context, and we will have the AI test. That's the channel name. Let's make it a bit more palatable. Cool, so we do have our list of messages. System User assistant, user assistant, user assistant. Cool. Let's now start working on the message queue. For this, we will import the async IO, LLM completions, and we will need to create two queues. So we will need to have a request and response queue. So let's do that now. So what we will be implementing here is mostly available in the async IO queues documentation. It will be heavily based on the example. So in the most basic layout, we need to do two things. Well, we need to do one thing, but we need to have our queue. So that will handle our actual queuing of the questions to the LLM completions. We need to have an input function that will handle those requests and then pass them on to the worker. So like basically add them and pull them from the queue. And we need to have a function to initialize our worker thread. So like create the task for the worker. In the LLM complete, we are creating a tuple which will contain our queue item. We will put this item in the request queue. This will be a blocking until we get the task done from the worker. So we put the request into the queue. In the queue worker, we are also blocking, waiting to get the new item. So once we get the item in the queue, in the request queue, we are unpacking the tuple. Basically, we're getting the same fields, which is our question, the context ID, and if we wanted to put it into the completion only function, which we haven't implemented yet, this is why we pass. So if it's not complete only, we are then waiting for the LLM completion, for the LLM chat completion with our question and context. And then once we do have the reply, we are marking this task as done. And we're putting the output, so we're putting the complete output into the response queue. This task being marked as done unblocks this. So we are now getting the response queue output, which is the completion output, marking this as done, and we are returning the completion. So now we can call this function from the Discord bot directly, and this will queue all of the requests and wait for each of them to be completed. So let's implement that in a bot. So over here, instead of the LLM chat complete, we are doing the LLM complete request, and we are not doing it from the completions, we're doing it from the request queue. So let's do actually replace that. So from request queue, import LLM. So now we have our middleman queuing, and we also need to add chat completion. So what was it? Complete only? Complete only equals false, as we haven't yet implemented the complete only function in the LLM completions. Check if I didn't mess up anything in the name. Complete only false. Complete only false. Okay. And let's try that again. Actually, before we try it, let's remove the previous context. So rm saved context AI test, and then run Python bot. Not mention is not defined. So we messed something up. Let's try that again. Bot line 24. It worked before, but obviously I must have messed it up. Right, Python bot. Okay, it looks like we will need to troubleshoot our queuing because it is not working. I'm guessing the message got received. You can check that there was a request here, probably. Try request queue. Oh, of course, yes. We didn't initialize the queue worker, so we do need to do init request queue in the bot. So on ready, we want to initialize our queue worker. We will need to also import it from the request queue. Okay, so let's do this init request queue, and then we actually have the request queue to pass on information to. Try again. Almost so blind. I didn't see that we have a runtime warning here. Init request queue never awaited. Oh, okay, that's not good because we need to wait for the request queue. We can also check if we're getting those messages. Saved context, AI test. No, of course, because we didn't correctly invoke them. Python again. So now we fixed the await bot. Okay, no warnings here. Hey, and we got a response. So that means that the queue is working. And let's try it out. We split the panel here. Now we have our context, and we should be able to send a few messages at the same time without it being overwritten. So let's try that. Okay, it's responding too quicker than I can type. Let's try that a bit more. Let's do it. Let's make it do some long responses. All right, let's queue up some questions. I'm just gonna copy paste some ready-made ones. Okay, so that's 3 questions queued up, and we should get all of them in order in the context once it responds. And this is a good way to actually test if we can handle errors as well. But let's look at the context first. So we had that, and we shouldn't be missing any of the last questions. So what are some of the benefits? What is the current understanding? What's the main principle? So we have all of them, which is great. Basically, that means that our context handling works the way we wanted it to. But let's generate some issues here. Let's try to break it. Let's give it too much context. I started it with a context of 1496, which is quite a lot, so it's gonna take us a while to get it to fail. There we go. Finally got an error. So the value error request token exceed context window, and then in our bot, lovely. Close this window. We don't need that anymore. We have OpenAI error, API error, invalid response object from API, internal server error. So we want to handle this. We know in our specific case, this will mean that the context exceeds the available context size. So let's start implementing handling for that. Okay, so now we have added this. So we were setting by default token exceeded true so that we can have a while loop that will basically try to get the response until it cannot get the response. So if we get this error, the API, OpenAI API error, we will remove the message at index 1. So we will start trimming our context, removing the old messages from it. It needs to be number 1 because our first message is our system message. So we're gonna do 0 index because it would remove the personality of the model. Give it a quick test. For that, I'm going to restart the server, but this time I'm going to set a really short context of 512. Okay, so the API server is listening. Let's launch our bot. And now we shouldn't see those messages even if we actually get them in the API. So let's stay on the API tab. Let's do, there we go. We got a lot of the error messages here, but we still got the response. Our bot didn't output any error messages because it handled all of that and removed a lot of context. And I mean a lot because we got quite a few errors until it got to the point where it was able to receive proper API request. I'm going to stop it now and start it again with a larger context so we can do some more trial and error for other things. Right, so we have the handling of the access context implemented. Let's work on adding the completion only function. So for the LLM complete, we can pretty much just copy this and use the completion instead of chat completion. Right, so over here, the difference is we're calling the completion and we are not passing all of the messages, we're putting a single prompt. So this is how it's specified in the OpenAI documentation. So we are just passing a single message and then we are returning the completion. Actually, I just realized that this will not work because we need to also pull out the details from the response like we did before. So like with the choices. 1 second. Okay, so now we are returning the actual text of the completion. So in our queuing, we want to be able to call the LLM complete, not the LLM chat complete. Let's go to the queue. And this is where we'll be calling it. So basically we just need this. Uh, and we're not passing the context ID because it doesn't have the context ID. Right, so we will have our completion output depending on if it is called with the complete only. So now in the bot itself, we need to implement the complete only. Let's look into that. So in the message start with @mention, we can implement the handling for the completion only. Let's maybe have it also start with something like exclamation mark complete. Okay, so we have our stripped message, and if the message for the bot starts with exclamation complete, we are calling the completion request queue. We are putting the message in the queue. The context will be disregarded, and we are letting the queue know that it will be complete only request. Then in the same fashion, we are responding with the response, and then we are calling return. The return here is important, otherwise we will run the same request for the chat completion request, which we don't want to do. So basically just like a single shot complete request that will happen here. And let's try how it works. Actually, before we do, While we are editing the bot, let's also add a handler for resetting the context. This will be something that will make it a bit easier for us in the future when we test the rest of it. So copy that. If message starts with reset. All right, we are specifying an exclamation reset command for our bot that will then execute the context handler reset context, which we imported here. So we need to import the context handler and just confirms with us that yes, the context was reset. Now let's test our bot. We should be able to do reset. Cool, that worked the first try. Let's actually confirm if it worked. Yeah, it indeed worked. So we don't have the AI test channel context anymore, which is great. And now let's test the completion. And we do have a response, which is okay. I'm not gonna read the joke, but let's see. We did call v1 completions instead of the v1 chat completions. So let's verify the difference here. Ronimira. Without the complete, we can start the conversation. And over here we can see we're getting the models and we're calling v1 chat completions. Okay, and let's check the context. And the context exists and stores it correctly. Cool. So now we can save context. We can do separate completions with like pinging our bot and doing complete. I think we're almost done here. We might want to give one slight improvement to our context handler where we can make the system message configurable. Let's add the so over here we're specifying a global variable for system message and then we're passing this system message to the chat. I think in the future videos we can look to make it configurable so we can change it on the fly. But what we did today is enough. So let's test it out and see how it behaves. Arrgh! I be Captain Blackbeard. Okay, I think that's pretty good. It actually got the system message quite right. One final thing that we are missing is a handler for direct messages. This is something that we can implement in the bot. Let's close this pane, it's distracting. So basically we want to check if the message is a DM and then that will not require the add ping, so the bot can respond directly to the DMs. Okay, so what we're doing here, we are checking if the message channel is an instance of the DM channel within the Discord channel object. Then if it is a DM, we are setting the context ID to the string of the message author ID. And finally, we are doing the one extra check for the responses. Basically, we want to either start with the at mention or respond with the DM. Basically, if it is in the DM, we don't need to ping the bot for it to respond. And let's show how that works. So now if I DM the bot, it will obviously error because I made a typo most likely. Let's try to fix that. So if the message is DM, that's how we called it. Try again. And just like that, we can chat with the bot directly in a DM without it requiring the ping. So let's summarize what we did. We added option to reset our context, and we are now storing it persistently in the files. We added the option to run a single completion without passing on the context. We added the option to have direct messages with our bots. So if we send them DM, they will actually respond. And then in the code itself, we added the option for the specification of the bot persona by setting up the system message. I hope you learned something new today. You can go make your bot better and have fun with it. Thank you for all your comments, and bye.